Thanks, everyone. So my name is Thomas Carr. I'm a consultant and software developer with CGI Federal. We're a US government-focused IT contractor and cleared defense contractor housed under a much larger global IT consulting firm called CGI. More specifically, I work on a product team there in the emerging technologies division that's called Secure Data Fabric. It's a cross-domain data sharing solution using some Web3 technologies. And so, like as a web app developer, I've had to dive into some of these technologies for my job, for my day-to-day work. And I'm here to present to the Ruby community that in our, I think, fair assessment of Web3 as being some nonsense, there's some interesting stuff to take out of there. Digital identity, or how I learned to stop worrying and love Web3. This will serve as a Ruby-flavored introduction to some concepts around self-sovereign identity. A little bit about myself. I went to the University of Tennessee. I did not study computer science or anything related. And for about 5 years, I worked across a number of non-tech roles like sales, marketing, and operations before doing a software bootcamp in 2020. I ended up in a Ruby on Rails API development role at a regional textile manufacturer called MWW. Shout out to the MWW devs past and present in the room. And eventually managed the IT department there for about 6 months as the company was transitioning to new leadership before landing at CGI Federal over in Knoxville, Tennessee. This will be the only slide I devote specifically to the term Web3, because it's not a term that I care to die on any hills for. It simply advocates for sort of a new architecture for web applications using technologies like decentralized protocols, things like blockchains and other distributed ledger technologies, and token-based economics. 2 out of the 3 of those, I think, are largely suspect and overhyped, starting with DLTs, like blockchains. They have some use cases. If you're curious, that's not what this talk is about, but we're using it for some things, and it does have some interesting functionalities. DeFi, all these cryptocurrency token schemes that you see a lot of hype around, I would highly recommend ignoring the vast majority of those. I have yet to see anything doing anything really interesting with digital tokens. The term Web3, I honestly categorize there right next to cloud as like a term that consultants like me and institutional capital like to coalesce around for the purpose of hyping their products and pumping their investments. I think that these technologies are often oversold and try to get into the hands of everyone, even though it's not great for everyone. And over time, the right use cases tend to settle in. So that's why I'm here to talk about digital identity, the piece that I'm pulling out of the Web3 stack that I think might be useful for Ruby web app developers. So we'll look at some baseline definitions about digital identity, why I think it's important, and how we can improve digital identity systems in our Ruby web applications. So what is it? What do we mean by digital identity? I'll be honest, I pulled this directly out of that first paragraph of Wikipedia for digital identity, and it'll serve as a fine starting place as we expand the definition. Digital identity refers to information utilized by computer systems to represent external identities like people, organizations, apps, and devices. Digital identity systems often need to be machine readable, meaning that the digital identity attributes that we provide to these software systems need to be readable and parsable by software. They need to have some sort of like endpoint you can reach out to verify their authenticity. And they need to be secure. Often we're talking about people's personal information or like secure IP for a company. And over the course of this talk, I'm going to be advocating for some new standards for digital identity, including using open interoperable standards which enable portable digital identity, using privacy-preserving protocols, and allowing for context-dependent digital identity, which simply means that you can, as a user, provide the attributes that you want depending on the context that you're in. Breaking out what I think are 4 major categories of digital identity for us as software developers. Right, we've got people, right, our human users of our applications. We've got a one-to-one relationship with a living person. the source of trust is going to come from government organizations handing out physical proofs like birth certificates and passports and driver's licenses. But we've got digital verifications as well, using unique identifiers like our biometrics, our devices potentially. For less secure systems, like CAPTCHAs are perfectly fine, where a user just submits their own form data. And then you've got organizational identity, which may be a business, also could be more loosely just a group of people, where for a business, you might have a tax identifier that you're using digitally. Physical identifiers might look like offices and the people working in that organization, right? Like a business without people or any physical spaces starts to look scammy, starts to look like some sort of drop shipping operation. And digital identity might look like the digital marks of the company, brands, the internal IT systems for that company. Then there's two important categories of digital workers or sort of software identities. On the sort of less intelligent side of things, software bots, right? Software-powered automation doing stuff for you on the internet, where the source of trust might come from the code. If it's open source, you can go and read it to know what's happening under the hood. If you can't read it, then you are sort of placing your trust in the brand of the organization running that code. Physical identity might come from hardware. If you're not running the code yourself, you're not going to see any hardware identifiers. Digital identity, these are things we're often familiar with: IP addresses, DNS systems, certificate authorities for apps running on the public web, or other types of public key infrastructure for things maybe working in an enterprise setting, kind of VPC. Then you've got AI agents. This is, I think, a new category, but largely growing, where you've got generative AI working autonomously on the internet, doing things for you, in a similar way to how our software bots used to do things. The source of trust might come from software, underlying algorithms, and data, though right now that's not really provided to us as users of these systems. Physical identity, again, might look like hardware. Digital identity maybe starts to have some characteristics of both software and people, but it's not clear yet how these generative AI systems are going to identify themselves to us on the internet. And I guarantee you, we're going to be bumping up against them on our web applications in the near future. Sort of double-clicking on some aspects of human identity that I think are really relevant to us as web app developers, where we typically have human users. With consumer-facing applications, our enterprise identity, or who we are at our workplace. That's usually things that are stored in an Active Directory system, like your maybe some authentication identifiers, your role, title, and team, the devices you've been issued, and then the HR information, your background check, your certifications. You also have many social identities, right? Spread across dozens of social applications across the internet, who you are on GitHub versus who you are on Facebook versus who you are on any number of social applications. You've got personal identifiers that you're maybe presenting on a profile to your friends and family. You've got your relationship graph, the people that you're connected with on these applications, and the things that you're creating, your content, your posts, your tweets, your toots. And of course, many of these websites, they have sort of an advertising model, and they're using various tracking techniques to potentially link your social identity from one application to another to build an even larger identity graph about who you are. So why is digital identity important, especially to us as web app developers? Taking a look at my GitHub profile, I've got some information here about myself. I've got my name, unique username. I've got where I work and where I live, and some linked websites. And I also have the content that I interact with and that I generate on GitHub, my Git repositories. So how did this information get to GitHub, and why do they have it? At some point, I filled out a form, right? As web app developers, we know forms very well. We build them all the time, and they're a useful tool for getting stuff, having users give us information about themselves or about their work. Now, often with these forms, we're filling out the same information over and over and over again, right? How many times have we signed up for some new web app that we want to go and try out, maybe compared to our own, and we fill out the same information, like our name, we give them our email, and we give them maybe some business information about ourselves. Probably have 100 websites that I have signed up for over the last 10 years, most of which I've never logged into again. And one of the reasons why these forms are useful, sign-up forms are useful, is that often our web apps want to create a unique experience for our users, right? We want to create some sort of tailored experience, and so we need some sort of unique identifier for those users. That might look like an email address. It might look like, if it's an enterprise application, maybe some sort of VPN access, or federated authentication using SSO. And then you use that unique identifier, you provision a session token, and then you go and fetch some data for that user. In an IT setting, as a federal IT contractor especially, we're often thinking about things like IAM or ICAM, where we're building like large IT infrastructure around rules processing. I give attributes to employees. I build rules about access. They can access cloud application A. They can't access on-prem application B. And some of the unique identifiers that we give to our users are things like emails. If you're really fancy these days, maybe you're using passkeys with devices. Maybe you're allowing your users to generate a unique username, or you're generating IDs for them using UIDs or an integer database ID. And we use that unique identifier to go and query our database, right? Or most of us are probably using some sort of relational database in our web apps, right? You go and query, you get your user's integer ID, and then you go and fetch all the other stuff, right? You go fetch their settings, you go fetch their content, you go fetch their personal information. And, as our applications grow, your Rails app SaaS business grows, your user count grows, your engagement grows, your users generate more content, right? Data grows exponentially inside our web applications. Eventually, the scale of data starts to paint a target on the back of many SaaS businesses, leading to what is a global problem now, which is data leaks across web apps, enterprise applications. Many of us, if you're not doing it, I highly encourage you to sign up for a service where you give them your email and you can see how often your stuff is being leaked on the dark web. Probably once a week, I see something from some old service I signed up for. I gave out my email, I gave out some personal information, and now it's freely available and likely being aggregated on various dark web websites, which enables attackers to develop really advanced phishing techniques. They know a lot about me. They can probably answer many of the security questions I've set up about myself, about my mother's maiden name, my first dog, all those kinds of things. So that's a little bit about why I think it's relevant for us as web app developers, why digital identity is important, why digital identity systems are important. So how can we improve digital identity in our Ruby web applications? And I'm going to introduce a couple new concepts, I think, to the Ruby community. One is sort of this overarching theme called self-sovereign identity, which really just means enabling your users to manage their own data using some new protocols. Usually it involves some sort of what's called a digital credential exchange, and I'll explain a little bit about what that might look like, where a verifier can take data and the trust of where that data came from is transferred to the credential holder. And it's this whole new model for digital trust on the web. There's this model called the trust triangle. We have an issuer, a holder, and a verifier, where an issuer, some trusted authority, I'll use as an example here digital driver's license, where an issuer, being the DMV of North Carolina, just like they would with a physical driver's license, you show up, you give them your proofs of your residency in the state, you hand over your phone, and they give you a little signed digital credential that you get to hold wherever you want, probably on some sort of wallet on your phone. And you get to go and present that wherever, whenever you want. As an example, let's think about like going to a bar, where if you need to go and prove that you're over 21, you're gonna show them your ID, and you're gonna give them a lot of information about yourself. Our driver's license usually have our address, our eye color, and our organ donation status. Digital credentials enable some really unique things where you can just choose the fields of data that you want to present, and the verifier can independently know that it came from the DMV of North Carolina using digital signatures and cryptography. The standard that I'm looking at here is called the W3C, Verifiable Credentials Data Model. W3C being international web standards body. This has been in development for several years now. It's quite mature. It's an open specification allowing for a set of claims, often looking something like JSON, keys and value pairs. And you wrap that up into a little cryptographic proof. And it's verifiable, it's tamper evident. It allows for things like selective disclosure, where you take that proof of your digital driver's license, and you can just present a little piece of data that says, I'm over 21. It's typically made up of a metadata, claims, and a proof, and here's an example of what that data model graph looks like. You've got the credential metadata, you've got the claim. So in this case, the claim might be I, an alumni of the University of Tennessee, where the University of Tennessee issues me this digital credential of my diploma, and I can go and hold it in my Apple Wallet. And it's signed by their private key on their IT infrastructure, and their public key is freely available to go and check somewhere, probably on their website. And I can go and present that to an employer for a background check. And they don't have to go and reach out directly to the registrar's office every time they need to go and verify that I actually graduated from the university, or force me to go and pay them $20. As web app developers in the wild, this is probably how you're going to see verifiable credentials using this standard called JSON-LD, or JSON linked data. Again, you've got your metadata here at the top. There's a lot of work being done in typing or schema attribution systems for verifiable credentials. So in this case, there's a type being set called an alumni credential, which has a set schema that you can go and look up. That way the verifier knows what the structure of the claim is. So again, this is a very simple claim. It says, I am an alumni of example university. And then over here you can see the proof that it gets wrapped up into. Like I said, I didn't study computer science. I take some of these underlying applied mathematics and cryptography for granted. But you say what cryptographic scheme you used, and provide whatever pointers you need for the verifier to go and verify themselves. Something I'm going to point out here is this right here. Did : example : some stuff. This is called a decentralized identifier, and it's also a standard being developed under W3C. Allows for, it sort of looks like a URI, right? Like a URL you'd put into your browser. And it's globally unique, and all DIDs resolve to something called a DID document. So as an example, right, did method identifier. Think like did : GitHub : htcar3, right? So the specification might be you go to github.com/htcar3, and that's where you get the data for the did document for me. There are lots of different did methods. Each did method has a different specification for how you get that JSON data. But it works similarly to like a database identifier, right? Where instead of an integer ID for your database, where you go and look up the user ID and you go and fetch all that data in the row, you might allow your user to go and store their own data using this specification. Has a pointer to the data. You can go and fetch that data when you need it to present it for helpful stuff on your web application. There's a lot here in decentralized identifiers, but here's a little snippet of code that I've been working on a parser for decentralized identifiers using the did-web standard, grabbing this did-web for the identity foundation and resolving to the document stored on that website, basically making claims about the ownership that website has over their did and did key. This is, again, a standard for what that did document might look like. I take some of this for granted. I know that it basically proves that the identity foundation has the rights to that decentralized identifier using their public and private key. You use that to decode the signatures there. There are a lot of use cases beyond just digital identity, self-sovereign identity for verifiable credentials. In my work, we're using it for cross-domain data sharing, allowing federal agencies to package up data, pass it over to other federal agencies in a way that is verifiable and secure. There's some interesting use cases around like global shipping providers where a company is sort of wrapping up document exchange, like shipping manifests, turning it into a credential, and allowing global shipping providers and port authorities to be able to use this digital authentication scheme. It's also a whole model for digital trust, right? Think like peer-to-peer communication, where if I'm messaging with someone on some messaging application like LinkedIn, maybe I force a verification check to say, hey, person on the other side here, can you show me your verifiable credential, prove to me that you are who you say you are, and I can independently verify the authenticity of your credential. Or alternatively, maybe you're interacting with a software system, right, or an AI bot, and you want to confirm whether you're talking to a person, or I'm talking to some automated software bot from Comcast, or some sort of generative AI system. And ultimately, we're talking about verifiable data provenance, where you take any data, right? This looks like a certain structure, but you can sort of envision any sort of structure of data where you take it, you wrap it up into a little cryptographically verifiable envelope, sign it, and you can pass that off to whoever. In this case, enabling your users to hold some of their data. You get to offload some of that data from your own system, which I think most of us, we don't really want more user data than we need. So you get to offload some of that responsibility, enable your users to have more control, choose their own sort of privacy path. And right now, the tooling for Ruby is very limited. My team, we're not building a ton in Ruby, but my goal is to try and build out some of the underlying libraries so that you could just mount on essentially a gem onto your Rack app or your Rails app and be able to run sort of a self-sovereign identity service just like you would with like Sidekick or Devise. So the didx gem there is sort of the beginnings of some did parsers. I support did web right now, working on did key and a few other core did methods. And coming soon, hopefully, is a verifiable credentials gem for creating, issuing, and managing verifiable credentials. You can sort of see a dummy demo of what a credential exchange might look like. If you go to verify.com, or if you go to, there's a little link there, verify.com/BRR. You can go get your verified Rubyist credential, which has zero verification at all. To use it, I will warn you, you do have to have Microsoft Authenticator. Microsoft Authenticator has an identity wallet that they built in, and they have a cloud service called Verified ID that I'm using to generate and read verifiable credentials. So that's my talk. My goal is to try and at least get Ruby developers, web app developers to think maybe a little bit differently about how you're managing data for your users. Here's some tools, right? The days are still early about what it really looks like to implement self-sovereign identity in our web applications. We're working on it. I hope to make it really easy at some point for Ruby developers. That's it. Thank you, guys.